Welcome to this video on the topic of trigonometry. In this video we're going to have a look at something called bearings. Now bearings are a mathematical tool we can use to express distance with a direction. Now bearings can come in two different flavors. You have true bearings and you have conventional bearings. Now a true bearing is a distance with an associated direction relative to north. The way in which we can denote a true bearing is in two different ways. We can either go 23 degrees and we can put a little t underneath that, and that denotes a true bearing. And the way in which we express it is like so. So you have a little arrow pointing upward north, and then you stretch to the right 23 degrees and you draw an arrow. So that's one way you can show a true bearing. The second, or the alternate way, is we can stick a 0 in front of the digits. So we go 0 to 3 degrees, and this also represents a true bearing. The representation is in fact exactly the same as the first method. So two different ways of representing the same information. Now the second type of bearings we can use are called conventional bearings. So conventional bearings are always represented as a direction relative to two explicit directions. So what do we mean by that? Well, suppose we have a similar diagram to what we had before. So we have an arrow and we're pointing upwards to 23 degrees like before. We say we're starting off at the origin and finishing at point A, and we are pointing north like here. Now for a conventional bearing, what we do is we reference it relative to two different compass directions. So we've got north and we have east, and down here we have south, and the west isn't represented because it's not necessary. Now the way in which we can write this is we go, this bearing here, it is 0 to 3 degrees true bearing, but as a conventional bearing we rewrite this as north 23 degrees east. So north 23 degrees eastward. So what we're looking at is we start off north and we branch outwards 23 degrees towards the east. So this representation here, this is called a conventional bearing. Now another example we could do is we could go 135 degrees as a true bearing, and then we can represent this using our diagram like so. And we're going to be 135 degrees. So rather than being in this top right quadrant, we're going to be down in this direction over here. Now the measurement itself is going to look something like this. And putting the markers on all of the axes, we've got north, south, then we have east. What we're looking at here is we're looking at the angle we see inward here. So it will be 135, and then there's this angle theta in here. Now the theta itself is going to be 180 degrees. Take the 135, which will equate to being equal to 45 degrees. So what we can say for the conventional bearing layout, we go, this is equal to south 45 degrees to the eastward direction. So south 45 degrees. So you start off by going south and then you branch eastward by 45 degrees. And that's how we represent it using the conventional bearings. So up here we have the true bearing, and down here we have conventional bearings. Alright, let's have a go at doing a few examples. So going downward, we have example 3. Draw a diagram and then write the conventional bearing. So what we've got over here for A, we have 45 degrees true north. So we're going to have a bearing that's going to look something like this. So we start off by drawing the representation. Draw it here. And this is going to be 45 degrees relative to north. So it's going to point upwards like this. And I'll label this as the origin and this as point A. And this is north. Now we want to be able to convert this to a conventional bearing. So I'll draw a eastwardly direction here and label that east and label this one south. Once again, I'm going to leave west off because it's not necessary in this particular diagram. I'm moving this across just for the sake of space. To be able to calculate the conventional bearing, we're going to be starting off north and then heading east. So what we're going to write is we're going to go, the conventional bearing will be north 45 degrees east. So it's a nice simple one. It lines up quite accurately with the true bearing. Not much calculations to be done here. So we start north, we sweep 45 degrees to the east. Alright, let's have a look at the other 3 examples. So we have 150 degrees true north. So once again, we start off by drawing a diagram. So we get our rulers out and we draw a little compass. We're going to mark the northerly direction and the southerly direction. And then we're going to be going 150 degrees. So we're no longer working in this first quadrant. Rather, we're working down in the bottom right quadrant here. So 150 degrees, it's between 90 and 180, so it goes down like so. I'll mark it out. The origin is here and point A is over here. And what we've gone and done is we've moved 150 degrees like so. Now, because we're going to be working in this bottom right quadrant, rather than referencing the conventional bearing relative to north, we're going to be doing it to south because we're closer to the southern pole. So because of that, we are going to be wanting to get the angle of interest, which will be theta in here. So to calculate theta, from north to south, that measures 180 degrees, and therefore we've moved 150 degrees from north. So theta in this case is going to be 180 degrees take 150 degrees. So in this instance, we're going to get a direction of 30 degrees. Now, to be able to write this as a conventional bearing, we're going to go south 30 degrees east. So we start off from the southern pole here and we sweep 30 degrees toward the east. And this is how we write our conventional bearing. So this is our true bearing and this is our conventional down here. Okay, so that's example B. Let's have a look at example C. So in example C, we're going 350 degrees, 15 degrees, true. So we're going to be well past 270, so we're going to be in this top left quadrant over here. So that will look like something roughly like that. So we're going to start off at north and sweep all the way around, so 315 degrees. Annotating the rest of the diagram, we have north, south, east is not shown, but we have west over here. Now, once again, we're looking for this interior angle here because we're going to be going from the northern pole in a westerly direction, but we're not sure how much. Today, we'll call this phi, and then we're going to write phi equals. Now, the full rotation of a circle is going to be 360. So we go phi equals 360 minus, and in this case, we're going to go 315. That will yield the angle in which we sweep from a northerly direction to a westerly direction. This will come out to be, I believe, 45 degrees as well. So therefore, the conventional bearing for this particular diagram, or the conversion of true to conventional, is going to be north 45 degrees west. So we start at the North Pole and we swing 45 degrees to the west. Alright, that's example C. Now let's go to example D. This is where we change it up a little. So we're going to start off once again by drawing a beautiful diagram with a ruler. And then we're going to sweep 200 degrees from the North Pole. This is going to put us roughly down in this direction here. So that will yield a swing of 200 degrees. Marking the poles on our compass, we go north, south, east is not shown, and then west. What we're looking at is the angle between here and here. So we'll call this one, let's call it alpha. Now, alpha is going to include some of the 200 degrees in here. So the expression we're going to write to calculate the value of alpha is we're going to go alpha equals, and we know that between the North and the South Pole, it's a straight line. So it's going to be 180 degrees. And we're interested between the difference between 200 and 180. So we go 200 degrees, take 180 degrees. This is going to yield a result of 20 degrees. So the conventional bearing for this particular instance is going to be starting from the South Pole, we go south 20 degrees towards the west. And thus we derive our conventional bearing. So, in summary, what we had a look at in this particular video is we had a look at a thing called a true and conventional bearing. So bearings being a mathematical tool we can use to express distance with a direction. We then had a look at the true bearing, which is just a means of representing a direction relative to absolute north. Then finally we had a look at some conventional bearings, or the means of representing a conventional bearing, that being a way in which we represent a direction relative to two compass directions. So northeast, northwest, southeast, southwest.